Okay, you guys, so we're going to look into lesson 1.5, and we are going to actually skip over this model and discuss part. We are talking today about solving inequalities, creating them, and graphing them. Okay, and we know that inequality means that when something is not equal to something else. So if it's not equal, it has to be greater than or less than, or could say greater than or equal to or less than or equal to. Okay, so solving is exactly the same as what it normally is when we're doing equations. So we just have to start like normal. So we're going to start here at example 1, and we're going to do exactly what we've been doing. So I need to distribute the -4 because it's on the outside, and I'm going to have negative 12x plus 4 plus 6x is greater than or equal to 16. Okay, combine like terms like we have been. Negative 12x and 6x would give me negative 6x plus 4 is greater than or equal to 16. I would need to subtract 4 from both sides. So we have negative 6x is greater than or equal to 12. And if I divide by negative 6 on both sides. Now, if we divide by a negative, if you'll remember, something special happens. So if we multiply or divide by a negative number, the sign flips the opposite direction. Okay, so greater than or equal to becomes less than or equal to. So I have x is less than or equal to -2. Okay, there's that. Now I need to actually graph it. So I'm going to draw my number line. I don't ask that you put very many on here, but if -2 is here, I'm just going to go -3, -2, -1. Remember the difference between open and closed circles. So if it's an open circle, it's greater than or less than. If it's a closed circle filled in, then that would go for less than or equal to, greater than or equal to. Okay, so here's your remembering for your symbols. So this one is less than or equal to, so I'm going to fill it in, and less than goes to the left, so I'm going to color in to the left. Okay, so pause and see if you remember how to do the next two. We've got -6x minus 6 is less than 10. Add 6 to both sides, and we get -6x is less than 16. Okay, and then divide by -6 on both sides. Now, this is not going to come out evenly, so we're going to have a fraction, all right? And that's fine. So we have x is greater than, because we have to flip it, right? And then if we divide both of these by 2, we get 8/3 negative. Okay, and if I want to graph it, okay, nice and easy. So this would be -9/3, -8/3, -7/3. All right, I'm going to have an open circle on 8/3 because it is not equal to in our symbol, and greater than means I shade to the right. Okay, good job. Same thing here. Let's distribute both of these, and we've got 8 minus 4x is greater than 1. Subtract 8 from both sides. -4x is greater than -7. Divide by -4 on both sides. And x is less than, and then again, this is not going to come out even, so 7/4. Okay? Graphing it, draw your number line. And again, it doesn't matter which way you do it. So you could be 6/4, which is actually 3/2. 7/4, 8/4 is 1/2. I'm going to have an open circle on 7/4, and I'm going to be going to the left for less than. Okay, so example 2, we'll be solving them with variables on both sides. So again, same exact thing that we've been doing this whole time. If I want to get variables together, I'm always going to choose to move my variable on the right to the left side just because that's the way I like it. You can move it however you would like. This leaves us with 2x plus 19 is greater than or equal to negative 7. I'm going to subtract 19 from both sides. This gives me 2x is greater than or equal to negative 26. And then we have divide by 2 on both sides. Now this time we didn't divide by a negative, so we won't flip the sign. Okay? Then graphing, same thing. Just give me a few numbers. So I'm going to do negative 14, negative 13, negative 12. Remember, when they're negatives, they go in the opposite direction. We have a closed circle because it's equal to, and greater than means we're going to the right. Okay, so same basic steps we've been doing. Then on this one, pause the video, try it on your own, and then see how we did. So if you're back, I'm moving my x's to the left again. Negative 3x minus 5 is less than negative 22. I'm going to add 5 here. That's going to give me negative 3x is less than, and I have, 17? Negative 17. Divide by negative 3. And we flip because we divided by a negative. And then you can either leave it as an improper fraction or a mixed number. So this would be positive 5 and 2/3. So if I want to graph it, I could have 5 and 1/3, 5 and 2/3, and then 6. And then I'm going to have an open circle, and it's greater than, so I'm going to the right. Okay, so example 3, just more solving, and let's see what we end up with. These are special cases, so something should look familiar to you here. Okay, if I have negative 6x and this one becomes positive 15, greater than negative 6x plus 9. If I add my 6x over, then you'll notice that both of them cancel out at the same time. So we just had this with the equations. What you're left with, though, is 15 is greater than 9. So this isn't an equals or a not equals, or the same number or not the same number. You have to actually read the statement and see if it's true or not. So if 15 is greater than 9, which it is, and it's true, then this means you have infinite solutions, just like if the other one was true. You're just not looking for those same numbers, okay? On this one, 4x minus 5 drops, 2 distributes. So again, we have 4x, but now we have minus 6, right? So if I get rid of the 4's, and they're both gone again, now I have negative 5 is less than negative 6. Well, these are negatives, so that is not true. And if it's not true and you're saying no, then you need to be writing no solution. Okay? All right. Pause again. Do a couple on your own. Okay? If I add my 8's over, this is gone and this is gone. And this says 4 is less than 4. Well, no, it's not. 4 is the same as 4. So this is not true, which means it has no solution. Okay. Over here, distributing on this side. If I again add my 6's together, these are gone, and I've got -5 is less than -3, and that is true because of it being negative. So this would be infinite solutions. All right. Okay, last one, creating. And this is our word problem. So Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A, and which one from florist B? Okay, so florist A is giving us, remember we're comparing here, florist A to florist B, $4.75 per blue rose, right? So per rose, plus a $40 delivery charge. Okay, and we want to know when it's going to be less expensive, so less than B, which is $5.15 per rose plus a $25 fee. Okay, so if you have the movement like we talked, this is going to be subtracting $5.15 from both sides. Okay, that gives you negative 0.40R plus 40 is less than 25. If I subtract 40, that gives me negative 15. And then we need to divide. So R is greater than, because we're dividing by a negative, and we get 37.5. Now, that means you have to order more than 37.5 roses to make it cheaper. Now, 37.5 is not a number of roses that you can order. So you'd have to order 38 roses or more for florist A. Okay? If you ordered less than 38, florist B would be your choice. Okay? All right, so pause it and do the last one yourself. And when you're ready, join in and see what the answer is. So if florist B increases the cost per rose to $5.20, for what number of roses is it less expensive to order from A? So again, A is $4.75 per rose plus a $40 delivery charge, and we want it to be less expensive, so less than, okay? Then florist B is going to be $5.20 per rose plus the $25 fee. Okay, so let's try this one more time. Subtract 520 from both sides, and you get negative 45 cents plus 40. Let's subtract 40 again. Negative 0.45 is less than negative 15. Okay, divide by negative 0.45. Okay, and we flip because it's a negative, so R is greater than, and you get 33.3 repeating. So for this one, if you're going to order more, then 33 roses, you should do florist A.